So in slides 2 and 3, we're deciding if it's arithmetic, geometric, or neither sequences. So what you need to remember, I'm just going to call it the arithmetic, so I can say it a little better than what I've been doing. For this to happen, you have to have a common difference, because this is like our linear model. Okay, it's our linear pattern, if you will. Now remember, difference happens when we subtract. Now for it to be geometric, you would have to have a common ratio. Now remember, ratio is dividing, so these are the only two operations that you're going to be doing. Now what I recommend you do always is start with subtracting, and if it's not common, stop and try to divide. Now notice that it says neither. A sequence can be neither if it doesn't have a common difference or a common ratio. So just, that's what that means. But for this, we're either going to have a common difference or we're going to have a common ratio. So all of your work gets done on the calculator. When you're finding the common difference or the common ratio, you start from the back of the sequence. So we start with 729. We're going to try the difference, 81 minus 9. Notice that 648 and 72 are not common. They're not the same numbers. So automatically, it's not linear. It's a sequence, but it's not that. So then try to divide. Try to find the ratio. We start from the last term and then go to the next term. So once again, this is the work that we need to see. All right, I get 9. How about if I do 81 divided by 9? I get 9. 9 divided by 1, I get 9. That's a common ratio. It's common because it's the same. And it's dividing, which is the ratio. So this is going to be a geometric sequence because the common ratio is 9. So you have to tell me what sequence, and you have to tell me if it's a common difference or a common ratio, and then what the ratio is. So for slide 3, you're going to do the exact same thing. Is this going to be like a linear pattern, or is it going to be a geometric pattern, which is exponential, okay? The arithmetic is finding the difference, so we always want to try to do that first. So in the calculator we go, using the Desmos calculator. Do 80 minus 91. 91 minus 102. And you have to do all of them. You got to make sure that it is common throughout. Since it's a common difference because we minused, that's the arithmetic one. And notice that it's a negative 11. If you start from the beginning, 113, and take away 11, you're going to get the next number in the sequence. 102 take away 11 is going to be 91, which is the third term in the sequence. So you want to make sure, if you need to, double check that that negative 11 makes sense. Now for number 4, through the rest of the slides, we are talking about geometric sequences. So geometric sequence is all about the ratio. The R is going to be the common ratio. The a sub 1 is going to be the first term. So in this sequence, in the first sequence, the first number is 2. Now what about the r? Let's work backwards. 16 divided by, because I said it's a ratio, 8. All right, cool. What about 8 divided by 4? Fantastic. 4 divided by 2. All of those get you a common ratio, which is 2. Now for the second sequence, what is the first term? The first term is 3. How do I find the common ratio? Work backwards. Negative 24 divided by 12. 12 divided by negative 6. Negative 6 divided by 3. My common ratio is negative 2. For the third sequence, our a sub 1 is 10. That's our first term. Have to work backwards for the ratio. 2.5 divided by 5. 5 divided by 10. You can put 0.5, you can put 0.5, does not matter. Check it, and you're good to go. Now slide 5 and 6 deal with recursive. Now remember, we are in a geometric sequence. So whenever you see recursive or explicit, we are talking about a common ratio. Yes, you could do a common difference, but that is not what we're doing right now. So we are in the geometric sequence part of our textbook. So you want to follow these steps. Step 1 says find the common ratio. So open up your calculator. And start dividing. Ratio is dividing. Start with the last number, go to the next number. Even if it's a fraction, use parentheses so the calculator can go. So notice that we have a common ratio, which is 3. All right, got that done. Find the initial value, a sub 1. Our initial value is 10 over 3. You're telling the reader where to begin the sequence. So the answer is going to be a sub n equals 3, parentheses, our previous term, you're going to just rewrite that. And then we do the semicolon to tell the reader where to begin. This is what you are expected to know on the test. Even though you're expected to know this on the test, this is what this means. If you notice here, this is our first term, our second term, our third term, our fourth term, and our fifth term. What happens if we want our sixth term? How do we get that? The whole point of this formula is to plug in what we know. We have a sub 6, and we know that it is 3, and then as a common ratio, and then we plug in the previous term. If you plug in the previous term, it's going to tell you the next term. So if you put that into the calculator, 3 times 270, it's going to get you 810. So that's the whole point of recursive for this geometric sequence. It tells you the term that's next. So if I wanted to keep going, I would do 3 times 8, 10, get an answer. 3 times that answer gets you the next. But for the test, all I'm looking for is the formula and where to start. So for number 6, same idea. Find that ratio. Use parentheses. Your parentheses are going to be very important. And then it gets easier. Now you can keep it as 0.2, you can make it a fraction, it does not matter. So our R is going to be 0.2. And then our A sub 1, our first term, is 250. So you're telling the reader where to begin. So we plug that in. We have our A sub n. We have our ratio, which is 0.2. We're going to write the previous term. And then we're going to do this semicolon 250 because we want to tell the reader where to begin. Now explicit. Explicit is a different formula and it's a different use. The explicit formula for geometric is what is written below. It will tell you the n term in the actual problem. It's the term you are trying to find. So common ratio, we use the calculator. A common ratio is 6. We identify the A sub 1, which is our first term in the sequence. Now the n comes from the actual problem. Our n is our 13th term because that's the one that they're trying to tell us to find. That should be a 3. All right, then you plug it in. This one you're actually evaluating, so step 4 says evaluate. So we have our 2, we have our 6, and to find the 13th term, we have to do the 13th minus the 1. So you should have A sub 13, that's our 13th term. Now, if you get a big number in the calculator, please don't worry. Remember, this is going up by 6, multiplying by 6 every single time you add a term to the sequence. So it's going to be a ginormous number. In math, when it's a huge number like that, we use scientific notation. So scientific notation, math. All right, in slide number 8, we are going to use the explicit formula again, and it asks what is the 8th term in the sequence. So right now there's only 5 terms. If we kept this pattern going, this sequence going, what would be the 8th term? So step 1 is always find the common ratio. It is a geometric sequence. So we kind of gave you that hint. So we start from the 6, divide by 36. 36 divided by 216. 216 divided by 1296. Notice that these repeating decimals are all the same. I recommend just making it a fraction when it's a repeating. So our R is going to be 1 over 6. It says identify the a sub 1, the first number of the term. And then the n, it tells us what term we're trying to find. So our n is going to be 8. So then we put that all together. The term that we're trying to find is the 8th term. We have our first term, which is 7,776. It's a decay because it's 1 over 6. And then remember, we have to do the 8 minus 1 that comes from the formula. It's always going to be minus 1. So then in the calculator, to find the 8th term, we need to put the formula in, raised to the 7th power. Sorry guys, this is a horrible writing. So that should be 7,776. And then we have the 1 over 6. And then 8 minus 1 is 7. So we're always going to do that because that's what the formula says. Use the calculator. All right, that's a yucky fraction, a decimal again. So I'm just going to make it a fraction. You can keep it a decimal. It does not matter. Either way, I will mark it correct, if it is correct. So the 8th term, if we follow this sequence, this pattern, it's going to be 1 over 36. Now slide 9 is not any more complicated, except it looks like fractions. It is fractions, so do yourself a favor and use the calculator. So when you do use the calculator, you need to make, all right, so using the calculator is going to be so beneficial, but you have to use the calculator correctly. So I highly recommend hitting the division bar first. So then you can see the numerator and then you can see the denominator. And then you have to use parentheses so the calculator knows that you want 81 over 256 sitting on top of that fraction bar. Then you want to use parentheses so you can tell the calculator, hey, what's on bottom? That 27 divided by 64. So it should look like this. You should always have parentheses in the numerator, parentheses in the denominator if you're grouping a fraction together. I'm going to start with my division bar, and I'm going to do the same process over and over again. And when you get into the school building and you use our calculators, it's going to be identical. We use TI Inspires here. You need to make sure the calculator knows that you are using the parentheses. So it will group the fraction together. It's just a wonderful habit to get into. And hopefully by now, after doing this several times, you know that the common ratio is 0.75. You can make it 3/4 if you want. Our starting value is 1. It's our initial condition, our initial value. Our n is what we are looking for, and that is our 10. So then we're going to plug that all in. We're trying to find our 10th term. We know our first term, our initial value, is 1. We know our common ratio is 0.75. And we know that we have to minus 1 in the exponent from 10. So 10 minus 1 gets you 9. So this is what's going to go into the calculator. Biggest mistake, students don't minus that 1. That is how you find the term that you're looking for. So if this pattern continued, if we were to find the 10th term, that 10th term, yes, that looks like a really long decimal. Let's make it a fraction, make our lives easier. This is the 10th term. A to the 10th, I'm sorry, not A to the 10th. The 10th term, A sub 10, gives you this fraction. So if the pattern repeated, this would be our 10th term. And yes, it's a crazy fraction, but guess what? All of these were crazy. So the more numbers or terms in the sequence, the harder the fraction is going to be. So this is where you want the calculator to do the work for you. So I'm sorry that my pen is so messy, but you can see it on the screen as well. All right, thank you, everybody.